Okay, so shall I go to the next?
Yes, sir.
Yes, sir.
Okay. So we discussed uh, we discussed supremum infimum density theorem, all these things we discussed. So we need to discuss further. Let is subset of R is non-empty and B subset of A is also non-empty. In question, I would like to ask, what is the relation among supremum, infimum of A and B? Its question is clear.
Yes, sir.
So A is a non-empty set, B is a subset of A. So A is a larger set, right? Suppose this is my set A and B is non-empty and subset of A. So B is smaller. Now from this figure, you can understand what could be the relation between supremum and infimum of A and B. So if this is A, then this is supremum of A. This is supremum of B. What is this? Infimum of B, and this is infimum of A. Now can you tell me the relation?
Supremum of A is always greater than or equal supremum of B, and the infimum of B is always greater than or equal infimum of A.
Right, so infimum of A less equal infimum of B less equal supremum of B less equal supremum of A. Right, so this is true in general situation, whatever subsets. So this figure is simple, this picture is simple, but in any case this is going to happen. Right. If you take A as an interval and B as a smaller interval, that in that case it is easy to see, but your sets might be very complicated. In that situation also it is going to happen. Right, and how to prove this? So how to prove this? So let B is subset of A. Let A and B are bounded. A is bounded. Therefore, B is also bounded, and therefore supremum infimum exists, no doubt. But we are interested in relation. So let supremum of A is equal to A1. Infimum of A is equal to A0. Supremum of B is equal to B1, and infimum of uh, infimum of B is equal to B0. Suppose, then what is our claim? What is our claim now? If with respect to this notation, what is our claim? Do you understand what is our claim?
A naught is less than B naught is less than A1. No, is less than B1 is less than A1.
Right. Claim. Okay, so prove one by one. You prove that A naught is less equal B naught, then prove that B naught is less equal B1, then prove that B1 is less equal A. Combine this, then we'll get this, right? So, since if X belongs to B, then X is in A, right? Am I right?
Yes.
Yes, sir.
Therefore, for each x in B, uh, for each, okay, for each x in A, x is greater equal A naught. Why? Why this?
It is the definition of infimum.
If you choose any x from B, x is in A, and A naught is the lower bound of A. A naught is lower bound of A, correct? Am I right?
Yes, sir.
So A naught is infimum of A, right? A naught is infimum of any element of B, it is also member of A, and every member of A is greater equal A naught, and therefore every member of B is also greater equal A naught. This suggests that A naught is a lower bound of B, because A naught is also lower bound of B, because every element of B is greater equal A naught. Fine. But what is B naught? Is the greatest. Right? So that what I should say next?
B naught is greater than or equal to A naught.
Right. A naught is just lower bound. But what is B naught? B naught is among greatest among all lower bounds. So what is the relation between A naught and B? Right. So this part is done. Right. So half part is done. Now B naught is less equal B1 is obvious, right? So B naught is less equal B1. Why? Because
Supremum of a non-empty set is always greater than infimum.
yeah, means lower bound is always greater equal upper bound. Right. Since B naught is lower bound, of B and B1 is an upper bound of B. Therefore, B naught is less equal x less equal B1 for each member of B, and ultimately B naught is less equal B1. So that is immediate. B1 less equal A1. So how to verify this? How to verify this? For each x in B, x is member of A. Right, x is member of A, and therefore x is less equal A1. Right? Why?
Definition of upper
Because
bound.
A1 is supremum.
Right, because A1 is a supreme of A and A1 is upper bound of A, and every member of A is less equal A1, so every member of B is also. So that A1 is an upper bound of B. But what is B1? B1 is the least of right? B1 is the least upper bound and A1 is just upper bound. So what is the relation? So that what is the relation between B1 and A1?
B1 is less than equal to A1.
B1 is less than equal to A1 because B1 is the least and A1 is just upper bound. Hence, what is the conclusion of these three things? Conclusion is A0 is less equal B0 less equal B1 less equal A1. So this is what we have. This is about subset, right? Relation between supremum and infimum of subset. Now we want to think about something else. So let A be a non-empty set. Let minus A is the set of, that means negative of elements of A, right? It is a non-empty subset of R. When we say negative positive, that means we are dealing with real numbers. So what is now set A? For example, to understand this, for example, equal to 1, 2, 3, 4. Then what is minus A? Minus A is a set of obtained from set A, right? Minus A is a set obtained from set A, that means elements from A, but just give negative sign to each element. So what is minus A?
-1, -2, -3, -4.
Right. So by our definition of minus A, this is minus A. Now, now I want to compare supremum and infimum of these two sets. Okay, what is supremum of A?
3.
Supremum of A is
3.
3 or 4.
It's 4.
Right. Infimum of A is 1. Supremum of minus A. What is supremum of minus A?
-1.
-1.
-1.
Minus 1. And what is infimum of minus A?
-4.
Okay, so this is just simple example to understand, but what could be the general statement now? Can we make some general statement from this, irrespective of this simple set?
No, we can't make any general statement
Why?
because
If you observe
because
here, yes,
if we take A is equal to -1, -2, -3, and -4, then minus A would be 1, 2, 3, 4, and then the relation would be exactly opposite what we observe here.
but you can observe something here. The supremum of minus A is
Minus
minus
of
Minus of
infimum.
infimum of minus A.
infimum of A, right? And for infimum of minus A is minus supremum of A, or supremum of A is equal to minus infimum of minus A, and infimum of A is equal to minus supremum of minus the same thing. That is observation from this. And is it true in general? So is it true in general?
Yes, sir, it is true.
Then what is our conclusion? Now we'll see the proof also in general, right? To prove something, the particular example is not sufficient. Why I am giving example? To realize what is actually the situation, so that you can imagine what could be the general situation. So supremum of A is equal to minus infimum of minus A, or infimum of minus A is equal to minus supremum of A, same thing. And infimum of A is equal to minus supremum of minus A, or supremum of minus A is same as minus infimum of A. So prove this. So what is our assumption? A non-empty minus A is what? Negatives of x in A. Okay, you can verify this with some different example. What is a different example? You can take set B is minus 1, 3, 5, minus 4, 6. And you verify with this also. The same conclusion is true in this case. And think about the interval also. 0 to 1, and look at the minus C. Therefore, it is true in general, so you want to verify this. Okay, so let supremum of A is equal to U. Suppose supremum of A is equal to U. Then U is an upper bound of A, right? Therefore, for each x in A, x is less equal U. Correct? X is less equal U. Is it right?
Yes, sir.
Right. So every element is less equal U. And therefore, by order properties, minus U less equal minus X for each X in A. Am I right?
Yes, sir.
Yes, sir.
That means minus U is less equal. Uh, can I say that minus U is less equal Y for every Y in minus A? Can I say
Yes.
this?
Yes,
Because
sir.
if you take negative of each element in A, the negative of each element is greater equal minus U. That means every element of minus A is greater equal minus U. Therefore, minus U is a lower bound of minus A. Minus U is a lower bound of minus A. Now, why it is infimum of minus A? Basically, what is U? U is the supremum of A. Now, you want to prove that it is infimum of minus A. How is it? What is our claim? Infimum of minus A is minus U. Once we verify this, then this is minus of supremum of A, that you can declare. Okay, so minus U is lower bound, that is one part is done. Why it is infimum?
Minus U is the greatest lower bound.
Yeah, that we want to verify, right? So if W is greater than minus U, because we want to prove that it is greatest among all lower bound of minus A, and if you take W, then want to prove that W is not a lower bound of minus A. Is it clear logically what we want?
Yes, sir.
Right. So our claim is कि minus U is somewhere here and it is lower bound of minus A. Greatest lower bound we want to prove that. Suppose you choose any W, then what we expect कि W is not lower bound. So minus U is the greatest lower bound, and that means we can produce some element or some element in minus A which is less than W. This is our aim. Okay, so let w is greater than minus u. What does it mean? Minus w is less than u. What does it mean? Minus w is less than u. Am I right?
Yes, sir.
And what it suggests? Since u is the least upper bound, since u is, because what is our basic assumption? U is the supremum of A, and therefore u is the least upper bound of A. We have whatever is this element minus w is not an upper bound of A. Am I right?
Yes, sir.
Because minus u is a smaller, so it cannot be upper bound. So, and therefore minus w is not upper bound means there exists element in A such that x is greater than minus w. Am I right?
Yes, sir.
Yes, sir.
That means minus x, so x is member of A and minus x is member of minus A, is less than w. Is it true?
Yes.
Yes, sir.
Yes, sir.
Thus, what is the conclusion? There exists y, which is minus x, in minus A, such that minus x less than w. That means y is less than w, because y is minus x. Right? What is the conclusion of this? What is the conclusion of this?
U is the U is, minus U is the lower bound of A, minus A.
Right, because the conclusion is if you select any element greater than minus u, you can immediately produce element in minus a which is less than w. Hence, w is not a lower bound of minus a, and therefore minus u is the greatest. Of minus a, right? And therefore infimum of therefore infimum of minus a is minus u, which is minus of u. U is supremum of a. This is what we wanted to prove. Clearly prove that. Similarly, you try to prove that supremum of minus a is minus infimum of a. You try to prove this with similar logic. Right? Is this clear?
Yes, sir.
Yes, sir.
Okay, now let a bounded subset of R. Suppose A is a non-empty and bounded subset of R. Then let alpha is a real number. Choose some alpha real number. So define set A plus alpha is x plus alpha where x is in A. Now do you understand what kind of set is this A plus alpha? Do you understand this?
Yes, sir.
And suppose alpha is equal to 1. Then what is A plus alpha? Can you tell me what is this set?
2.5, 3.5, 4.5.
Right, very good. That means every element of set A is added with alpha. So we are just and geometrically what it happens? 1, 2, 3, 4, 5, right? What is A plus alpha? This is set A, this is A plus alpha. So 2.5, 2.5, 3.5, 4.5 and 5.5. And one more element remaining. Which element remains?
6.5.
6.5. 6.5. So if you compare geometrically A and A plus alpha, what is happening actually?
It is shifting towards the
Right.
right.
Shifting of A to right by 1.5 units. It's shifting on the right side by 1.5 units. If alpha is negative, suppose alpha is minus 1, then shifting to the left side. Right, so this is a translation of set. Or shifting. Translation or shifting. Then the question is, what is the relation between? So then supremum of A plus alpha is equal to plus alpha, and infimum of A plus alpha is equal to infimum of A alpha. So this is true. That means the supremum also will get translated by same amount, right? That is what this suggests. If you translate the every element of set, then supremum will get translated. If you translate to the right side or left side, accordingly supremum will get translated. This is what. So you should write down the proof of this. So I will proof. I will leave this as exercise. You should think about it. Right.
Excuse me, sir.
Yes.
Can you just scroll up?
Yes.
Yes, sir. 1 second. Okay, sir.
Okay. Can you write down the proof of this? You try to write down, right?
Yes, sir.
Now, let A and B be non-empty subsets of R. Now, suppose for every y in B, y is less than or equal to x for every x in A. Do you understand this statement? What is this statement? For all y belongs to B, y is less than or equal to x for all x in A. This is what the statement is. At both ends there is for all. So the statement tell me such A and B for which this is going to happen. Can you tell me such sets for which this is going to happen?
Interval -1 to 0 and interval 1 to 2.
B is equal to -1 to 0 and A is 1 to 2, right? Very good. So what this suggests ki every element of B is less than or equal to every element of A, right? Every element of B is less than or equal to each element of B. So if you look at these two sets, so -1 to 0 and 1 to 2, this is B and this is A. So if you look at largest element of or maximum possible element of B, that is also less than or equal to the smallest element of A, that you can interpret it. So you can see another example. B is equal to -1 to 1 and A is equal to 0 to 2. Will these two sets satisfy this condition?
No.
No, right? Because, for example, y is equal to 1 in B and x is equal to half in A, right? For this, y less equal x not satisfied. Because geometrically what happens ki -1 to 1 and 0 to 2, so this is set A and this is set B and there is overlapping. And therefore, when this condition, above condition is satisfied, that means set B is completely left side of set A, completely. No overlapping or not like the common element. What point is, in such situation, then the question is, once you understand the situation, right? If you can imagine the situation, then what is the relation between? Then supremum of B is less than or equal to infimum of A. Is it true?
Yes.
Right. And now proof is really easy. How will you prove this? So let supremum of B is equal to B and infimum of A is equal to suppose A, whatever it may be. Our claim is, what is our claim? B is less equal A. This is our claim. Okay, fine. So now for each y in B, what happens? Okay, what I will do now, let y belongs to B. I will fix my y from B arbitrarily, no matter what y I am selecting from B, right? Then by given condition, y is less than or equal to x for every x in A. Am I right?
Yes, sir.
Yes, sir.
So logically what I am doing, I am just fixing my y. I am just choosing some particular y. And what is a given condition? That y is less equal every element of x. What does it mean? What does it mean?
X is less than or
Y
equal
is,
to B.
y is a lower bound of A. Am I right?
Yes, sir.
Right. So you choose any element from B and just think about that element. So stick to that element. Just think about. I have just selected one y and I am talking about y. But by given condition, y is less equal every element of A. So y is a lower bound of A. And therefore, what is the relation between A and y?
Y is infimum of A.
No, y is just lower bound.
Okay.
And what is our assumption? Ki infimum of A is A. So what is the relation between y and A?
Y is
Y
less than
is
A.
less than equal
Less
to
than equal to.
So A is the greatest lower bound and Y is just lower bound, right? And A is the greatest among also, so Y. When I say Y, you write down detail. This explanation you can give. So Y is less equal A. So now A is a particular fixed element. A is the infimum of A, so it is a fixed element. B is supreme of B, that is again fixed element. So what is this? Since Y belongs to B was arbitrary. Arbitrary means what? I just close my eyes and I choose one element from B, which is Y, and then I found that Y is less equal this particular element A. Right? Can I say that this is going to happen for every element of B?
Yes, sir.
Right? So Y was arbitrary, so Y is less equal A for every Y in B. Correct? Because I did not select Y as a special Y. I just closed my eyes and just put my hand inside B and I found some element and I came to conclusion that Y is less equal this particular element A. No matter which Y you select, so every time same thing is going to happen and therefore every element of B is less equal Y. What does it suggest? What does it suggest? A is an upper bound of B. Is it true?
Yes, sir.
Right. And therefore, but what is the least upper bound of B? What is least upper bound of B?
B.
B.
Right, B. And therefore, what is the relation between B and A?
B is less than equal to A.
Right, because A is just upper bound and B is least upper bound. And hence, what is the conclusion? Supremum of B is less than or equal to infimum of A. So, we are, this is a general proof, whatever your sets. Once your set satisfies the condition, which condition? Every element of B is less than or equal to every element of A. If this condition is satisfied, supreme of B and infimum of A. Right, and this is clearly general proof, no, not about particular sets A and B. Right. So, any doubt? Is this clear?
Yes, sir.
So, suppose I have, okay, have you studied functions?
Yes, sir.
Just started.
Yes, sir.
Also, I shared PDF about algebra, first chapter of algebra to your our group
Yes,
PDF,
sir.
right? So you can refer that also and try to solve the exercises from that, right? Okay. Now, want A is equal to uh, x plus 1 by x. Now question is, what is determine this set? What is supremum of A? What is infimum of set A? So you think about this, right? So from function point of view, alternatively, let f from r minus 0 to r be a function. Why r minus 0? Because
x is not equal to 0.
so at 0 1 by x is not defined, so r minus 0 to r defined by fx is equal to x plus 1 by x. So this is my function. Then all of you know what is the definition of range? Range of function f.
Yes, sir.
Yes, sir.
Fx in the domain. All those images, right? So x is the fx is called as image or value of function at x, and this is a set. But by definition of fx, what is fx? X plus 1 by x, right? And ultimately exactly our set A, x plus 1 by x is in R, correct? X is in R and x is not equal to 0. Therefore, range of this function is this. And therefore, if you want to determine this set, that means you want to determine the range of this function. And once you determine, you can understand what is supremum and infimum. Is it clear?
Yes, sir.
Yes, sir.
This is an interesting exercise. You should work it out. I will give you one more interesting exercise. X in R. Okay. Let me modify this. X upon square root of x square plus 1 x in R. Then determine this set B, and then find supreme infimum. That is different story. But first of all, determine the set. Or if I define f from R to R, fx is equal to x upon square root of x square plus 1, then find range of function f, and then you think about supremum, infimum, and all other things. Correct?
Yes, sir.
Right. So do you understand the problem?
Yes, sir.
Yes, sir.
Okay, so you think about these problems, because these problems will going to help you in algebra also, and algebra PDF, because I am teaching algebra to the another division, so syllabus is same, right? So you can find any doubt, any difficulty.
Excuse me, sir.
Yes.
Sir, actually, I want to ask a question, sir, not from this